Hey everybody, this is November 7th. Yeah, this is November 7th, Larry. I'm doing a bonus question today for y'all. So let's kind of do one together. What difficulty do I want? Let's do a hard. And then I'll go to the gym afterwards. Yeah, to do, and then we get to pick one randomly. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problems. I think Thanksgiving is coming up, and I think for Thanksgiving I think there's a deal on Leetcode, so I may get that. Still not sure though, to be honest. But if anyone is watching and wants to sponsor it, then I'll definitely do more of the questions. So yeah, I'm just a little bit cheap. Okay, so today's problem is okay, so it's not a whatever, right? Okay, 352 data stream as disjoint intervals. So I just want to make sure that it wasn't like a multi-threading problem, because I feel like I run into a couple of them and I don't quite know how to do them in Python. I haven't done the research on them. Anyway, that's a rant, but yeah. Hit the like button, hit the subscribe button, join me on Discord, and kind of do this problem with me if you like. So given a data stream inputs of non-negative numbers A1 to AN, summarize the numbers seen so far as a list of disjoint intervals. Okay, what does that mean? So you have 1, interval 1, 1, okay. Yeah, I mean, I think I think the idea is just going to be, there are kind of a lot of ways you can do it. There are a lot of tree structures you can do, but the idea is just finding some sort of log n way to add a number. I think. What is that? Y is up to 10 to the 4th. I don't know. I don't know if that matters. I mean, maybe it does. Maybe it doesn't. I mean, no, you definitely don't want to do a for loop for everything, so I think that's fine. You could also, so there are a lot of tree structures. You can also do what's it called? A linked list or something like this. Not linked list, a skipped list is the one that I was thinking of. But yeah, the way that I'm going to do it is with a sorted list. I don't know if I recommend it doing my way, because this is not a really friendly way, but I think the canonical way is just doing with some sort of tree data structure, and I'm just going to hack it with kind of this, and we'll see. This becomes, in a way, this becomes an implementation problem for me in a way, so we'll see. So the idea here is that we want to do, so this will contain all the non-intersecting things. And then when you add a number, we just have to, I guess we can also, I was thinking about doing it with sorted lists as I was doing here, but I guess you can, so based on this constraint, we can also use, what's it called, union find actually. Because then, you know, the idea is that you add a number, you union left, you union right, and that's it, right? Or, you know, if they're already in the thing. But let's keep it this way for now. We'll see. So we want to bisect left. I don't know, infinity say. Whatever, just right here. And the idea here. Oh wait, no, we want this to be -1 actually, so that it always gets the number that is. So basically, and I'm just working this out in my head. I mean, all this is implementation, so the idea is not that bad per se. But we're just trying to see if we can find like, let's say we're adding this number. Can we add duplicate numbers? Actually, I'm not sure. I guess it doesn't matter. But yeah, so this is the interval that would actually maybe when bisect right then. And then it should be this -1. So then now if it's Leetcode, then we want the next number. Okay, fine. The idea here is that we get the next number, and then we subtract 1 to get the one that's intersecting with this, right? If index is less than 0, maybe, then it doesn't do anything. That means that this Yeah, that means that there's no there's nothing that intersects it. So then maybe we do something like, and I'm not sure quite yet, but something like value to value inclusive, right? So it could returns inclusive range. Maybe. Let's just do both, right? So index. So let's just say left index is equal to this, right index is equal to left index plus 1, right? So okay, so left is equal to right, assuming that left index yeah, basically I'm just trying to figure out the merge logic. So yeah, so yeah, if this is greater than or equal to 0, meaning that it is in the thing, if sub.sl left index, so if the second index, if that number, or just write it the dumb way, why not? Left is equal to sub.sl left index, let's just be inclusive. If left of 0 is less than or equal to value left of 1, right? So that means that we're already included. So maybe this is an awkward way of writing it, but I'm just trying to go through the cases in my head, right? Otherwise, maybe if left of 1 plus 1 is equal to value, then we have to merge it, right? So then here to merge, we actually want to remove left, and then we just add to this is sloppy, but it'll work. And then we have left 0, oops, and then left 1 plus 1, which is same as value, of course. Okay. This is for duplicate reasons. Okay. Okay. So then if right index is less than, let's actually write this a little bit clearer because I think it's easy to mess up. And then same pattern here, except for now, basically, okay, I mean, we'll keep the same dubious pattern for now, but maybe another way that I can write this is a little bit different. Okay, let's just have a Boolean. Okay, and then now else if right sub 0 minus 1 is equal to value, then we merge, right? But this is just being about this is just about being exhaustive, I suppose, right? And then now, well, I was going to add another if statement about if they're both true, then we do stuff. The other thing is that if not added, then we just add value inclusive. That should be fine. Don't think we return anything for add, right? Okay. But then here, if the left index is also good, then maybe we should, do a quick math of this is kind of yucky though, but yeah, that means that basically we're trying to see whether we need to merge these two. I guess we can do it another way actually. So yeah, so okay, so then let's just, if index again is equal to right index minus 1, if left index is greater than equal to 0, then sub.sl that left or whatever index. So the second element, if this is equal to this first element, this is a little tricky because we have to figure out the other way that I can do it, to be honest. So I'm doing really funky things right now, but also, to be honest, we can merge. Am I committed? Because basically the other thing that I'm thinking about is that maybe we can merge on the get intervals thing, because get intervals you have to merge anyway, so maybe that's the better way of doing it, huh? In the sense that, okay, let's scrap all this. Maybe this is making it too confusing, right? So add numbers, we just okay, let me I do want to get rid of it, but let me just paste it somewhere else so that I don't lose it if I change my mind again. Okay, you'll see what I mean, because my idea here is that everything is going to be amortized. So let me just paste it somewhere. What's it called? What's this from? 52. Okay, so the idea here is that, okay, we just do this, and then now because everything is going to be sorted, then we just have something like right, so let's just say, right, something like this maybe, and then we get rid of this, and then now basically we have answer is equal to form equals to, say, how do we want to say it? So now for okay, let's just do it. I'm trying to be too clever in Python, but let's just do it the dumb way, right? Which is that, okay, so if r sub I of 1 is plus 1 is equal to r sub I plus 1 of 0, then we merge. It's really that simple. We have to kind of keep doing it though. So actually this is kind of like today's daily problem. So maybe we'll use a stack instead, right? So stack is equal to this, right? So then now, oops, the bottom I don't care. Okay. So then now for start and end in R, right? What do we do, right? So stack we append SE, that's fine. And then we basically go back, right? Meaning, yeah, or maybe we don't append it, but we go, okay, while length of stack is greater than 0 and stack of 0 or -1 rather, the top of the stack, if the second element is equal to or plus 1 is equal to start, then we pop the previous element. So previous start, previous end is equal to this, and then we append PS. This isn't quite right though, at least not as a, I guess this can only go once, so it should be okay, but it's a little bit awkward. And then do something like that, right? And then at the very end we return stack. I think that's right, but then now we do dot add, or let me check sorted list syntax. I mean we can do it individually, but I think maybe there's a add, like not an add, but I think there's a thing where you add a lot of stuff at the same time, but maybe I'm wrong. Append, so there's append, what? Extend, nope. So adding value, so there's add. Okay, maybe I'm wrong. Okay, fine. So then here, for SE and stack, sub.sl.add SE. Let's give it a spin. the reason why we did it this way, I don't know why there's a red dot there, is that it allows us to, in theory, allows us to amortize this anyway, because we have to print it out, so we have to go through the entire list anyway. There's no way to go about it, so why not compress while we're there? Obviously this is wrong because it's not printing anything, so let me just double check. So it does look okay, but then so why is this? Oh, whoops. Okay, so then how do I SE? Okay, give it a spin. Okay, so that looks good now. So did I print anything? No, or at least I removed the print statement. So let's give it a submit. Only thing I worry about is maybe time limit and maybe also just a lot of silly possible mistakes. So let's kind of take a look. Taking a while to judge, so maybe this is going to be, oh, huh. That I did not expect, to be honest. But, oh, that was one thing that I did take care of, but did not in this case, is the duplicate numbers. So I definitely possibly mess up on the duplicate numbers. Yeah, because you can see the 6 happen. Because that was the other thing where I was checked for, and then now I did not. How do I solve this then? So, I mean, it just means that we didn't. I forgot about this case because I was just so focused on the other stuff, or I don't know. I mean, just one of those things. Okay, so now what we want is, so okay, we see this, so this is whatever, and then the other thing is yeah, maybe I just do it this way. This is kind of yucky, but let's at least kind of look it up for now. So if this is the case, then I think we also do this, because the bigger numbers will be in the back, but this isn't quite enough, because it could have been in between, right? So yeah, I assume that, yeah, there's like a 7-7, for example. So that's not quite enough, but at least it got rid of a lot of the stuff. I think now all we need is, I just didn't think about this deep enough. What we now have instead is just 2 intersection, right? So that means that all we need is now min of this and max of, I think that's right, but this condition has to be is a little bit wrong. I think this will be good, but let's give it a submit again. Let's just see. But basically, this is just I guess that's right. But this is basically now you have now 2 adjacent intervals, and then I'm merging them together. And because these things are already sorted, I took some liberty on how, like usually you need more if statements, but because of some of the properties, I was half guessing that this would be a little bit more correct, or that wouldn't be more correct, just as correct, I suppose, and that worked out. Okay, so yeah, definitely a little bit silly mistake, because I even, you know, if you watch the earlier video or early parts of the video, I definitely talk about you know, I definitely talk about what happens when you have duplicate numbers and stuff like this, but I think I just forgot about it. And also, to be honest, there was the other second thing where, no, I think that's just because of the duplicate numbers, I guess, actually. So there definitely are some edge cases, but we're able to handle it. This is, so what is the complexity here, right? This is going to be log n, this is O of 1, I guess, and this is O of, I think this is O of n log n, but it's kind of, I mean, it is, but I want to say that a lot. I mean, I guess it's just n log n, but keeping in mind that each interval can only be merged. So there is some amortization here, and it's not n log n per core. It's n log n total amortized across all the numbers that you call, meaning all the number of times that you call numbers or add number. The reason for this is because when you add a number to add a single interval, what happens there is that can only be merged once, right? And otherwise this takes linear time anyway, because you just have to print it out. So you can't really do better than that. And the log n gets amortized because each number can only be added once, obviously, and also removed and merged once on the, so yeah. Though this part I think is a little bit awkward in that, or at least that's what would be the case if I had a better implementation. Because I think what I end up doing is that I forced this anyway. So maybe I'm lying here now that I noticed. I forgot about that. But if you do like if you do a slicker way of just going through the sorted list and then merging adjacent elements, I think that would actually be what I just said. But because the way that I did it was a little bit lazier, that is actually not what I said. So, but yeah, see if you can do it at home. Apparently this is still pretty good on the timing, so I'm not going to complain too much. But yeah, that's all I have for this one. So let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.